So we are referring to the steady flow and streamlined flow of liquids. Whatever volume of the liquid is entering the tube, I'm applying this for steady flow, turbulent flow. Two types of liquid flow. One, what is called the flow of fluids, or precisely saying, the mechanics of the flow of fluids. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In my yesterday's session on fluids, we discussed Pascal's law, we discussed applications of Pascal's law, Archimedes' principle, and general conditions for a body required for flotation. In my today's class, we will learn about fluid dynamics, something called streamline flow, turbulent flow, equation of continuity, and so on. Now, fluid dynamics is a branch of fluid mechanics which deals with the flow of fluids. Odidivallva? Dynamics means motion. Fluid dynamics, where we discuss the flow of fluids, or precisely saying, the mechanics of the flow of fluids. Now, the nature of description is based on these parameters. A fluid is incompressible. You cannot compress a fluid as we do a gas molecule. Liquid is non-viscous. It's not jelly type. It's not that gel milky type. It is non-viscous. The flow of liquid is steady, and this flow is irrotational. We say irrotational flow of fluids. So therefore, students, now when we try to analyze fluid mechanics, we say it is the dynamics of the motion of fluids. A fluid in motion, mechanics of fluid motion, which depends upon the incompressibility of the liquid, non-viscous property of the liquid, steady flow of liquid, and irrotational flow of liquid. Now, to begin with, we will now understand two types of liquid flow. One, what is called as steady flow, which is also called streamline flow, and the other one is called turbulent flow. So we are referring to the steady flow and streamlined flow of liquids. Here is a pipe, students. I consider various points inside this pipe. Point A, point B, and certainly a fluid is flowing through this pipe. The first particle of the fluid enters the point A with a velocity VA, passes through the flow of pipe, enters the point VB and goes out. The first particle. The second particle of the liquid again enters the pipe. It is passing through the point A with the same velocity VA. It passes through the point B with the same velocity VB and comes out. And therefore I say, any particle of the liquid passing through A will have the same velocity VA, and passing through B will have the same velocity VB. Then such kind of a flow is called steady flow, orderly flow, or what we call as streamline flow of liquids. So it is the type of liquid motion where every particle should have the same velocity at any point within the region of flow. Streamline flow or turbulent flow. At every point, the particle of the liquid passing through will have the same velocity. It is streamlined, channelized, orderly flow. Now, when the velocity of the liquid crosses a certain value called critical velocity. So above critical velocity, the flow becomes turbulent, non-steady, which means at every point, the particles will have different velocities. Now they are not streamlined, they are not channelized. The velocity, the smooth flow velocity of the liquid is broken down. The liquid has attained critical velocity, which means now that orderness is broken down. It is not a steady flow. It is called turbulent flow. So, if the velocity at every point of every particle remains the same, it is steady flow or what we call streamline flow. At every point, if the velocity goes on changing above a velocity called critical velocity, then the flow becomes turbulent. Next one, very important, something called equation of continuity. When a liquid flows steadily, I'm applying this for steady flow, turbulent flow, no, streamlined flow through a pipe of varying cross-section. Cross-sectional area varies, half a zord cross-sectional area. The product of cross-sectional area and speed of the liquid remains same. So A into V remains constant. Product of cross-sectional area and the speed of the liquid remains same. The volume of the liquid entering one end of the tube will be equal to the volume of the liquid coming out of the tube, because the product of cross-sectional area and volume is remaining same. Whatever volume of the liquid is entering the tube will be equal to the volume of the liquid coming out of the tube. If V1 is the speed of the liquid as it passes through the area A1, and V2 is the speed as it passes through the area A2, A1 V1 equals A2 V2, or A into V is constant. And this is what we call as the equation of continuity. So here we learn, students, because the product of cross-sectional area and volume or speed is remaining same, whatever volume of the liquid is entering into the pipe should be equal to the volume coming out of the pipe, which maintains an equilibrium of flow. Equation of continuity with respect to streamline flow. How that streamline is maintained, that is because of this condition. And this is called equation of continuity. So understand, basically the flow of a liquid is characterized because of its incompressibility, non-viscous nature, because it has irrotational flow, and the mechanics which describes all these things is called fluid mechanics. So in my tomorrow's session, I will come up with a beautiful concept called Bernoulli's principle. Until then, have a nice time. Thank you.